Here are some 3D printed models I recently made using a technique that I guess I would call slicerless printing. So instead of generating a 3D model like a mesh and then slicing it using a normal slicing software, I instead wrote a program that just takes a 3D Bezier curve and outputs G-code directly. So these first two small examples are things that I printed a while ago. This first shape is generated by wrapping a sine wave around a circle and then rotating it as it goes up, I think. I don't have the code that made this anymore. It's a little bit under extruded because the layers don't adhere super well. And some of these features are really fine, and I think I was printing too fast. You can see here where the feature size is bigger, it is pretty well adhered. This second one is also a sine wave wrapped around a circle, but every other layer is offset by a half of the period. And so it really only has layer adhesion at those nodal points. So this looks pretty cool and it's pretty squishy, but if I did this again, I would try and get better layer adhesion. You can see that it only is one sine wave, but together they make these voids. So then last week I revisited this idea by starting with a closed Bezier curve that I just drew in Inkscape, which is either the top or the bottom on this model. And then by applying some sort of transformation function to that curve and then just moving that up as the next layer, we can print out any of these shapes. This one, I had generated too many intermediate points, so the G-code file was huge and the movements were too small, and so we ended up getting blobs. I had the idea to fix this from a CNC Kitchen video, which was really helpful, even though that was for fixing a slicer setting. If I upgraded the printer firmware to use a recent version of Marlin, I could actually just generate the G-code with the Bezier curves directly. And I think each of these, they're all starting from the same Bezier curve, and I think there's only 8 segments or something. So it would actually be really cool that each layer would only need 8 G-code commands or something, instead of generating a linear move about once a millimeter, I think is what I have it set to for the rest of these. This one was much finer than that. Again, this is after resolving the resolution, so it didn't print so many and I didn't get those little blobs anymore. And these are nice and flexy. So then these two models are related in that the transform function, starting with this closed curve, just rotates the layer below it by a small amount. And I just chose some target rotations here. If we look at the cross-section view, it rotates from here to here to here to here to here. And then in between, we just interpolate smoothly with a Bezier curve. And you get this nice rotation between those without having just like a sharp corner here. And so some of these rotate too much and are too far away from the lower below them. So you end up with these voids, which, I don't know, I'm sure you could fix by maybe extruding more or somehow limiting the rotation that you have, or once you generate the curve, maybe fix it up by looking at the layer below it and ensuring that no point is further than some threshold away from the layer below it. And then this one uses the same idea, but it just plays with different, sections of rotation between the points. And you can see it ends up with the same, because it's very, very steep here. So this looks pretty cool. And then this one is the same idea, but instead of rotating the curve, we just scale it inwards and outwards using that same Bezier interpolation, so that we get this smooth transition between all of those scale points. So this shot clearly shows the original curve, which is kind of nice. And then the most interesting thing, which I could have talked about with this, but this one shows it really well too, is that, and so all of these are actually printing in a spiral mode, similar to vase mode or spiralized contour, I think it's called in Cura. But so it's just one continuous move, and it's not layer by layer. And so, but what's really cool is that we can still use that even when the curve is self-intersecting. So here we actually start with the same exact closed Bezier curve, and then this one uses a different function that just transforms the curve, which is the layer below it, and we keep stacking that up, and we end up with this kind of pointy, sharp line shape, but you can see that it self-intersects itself a whole bunch, and it does so down in the model also. And you can see here, this is one that actually came from the other side. But so since it when it gets back to its intersection, it's actually just slightly above, and so it doesn't run into anything. So I think this is the coolest one, because if you tried to generate this shape as a true STL mesh, for example, and then slice it, well, I'm not really sure what a slicer would do with that, but I also have no idea how to model this shape in any kind of 3D software that exists. And even if you could, I think the file would be huge, because the description as the set of curves is much smaller. This animation shows how the curve transforms as it moves up the layers on the last model that we looked at. And here's a render from Blender, which is how I was previewing the models before they were printed. Alright, hope you found that interesting. Bye.